Hello friends, I welcome you in lecture number 24 on logic. In this lecture we are going to discuss that how we can obtain principal disjunctive as well as principal conjunctive normal form of the given statement formula. In earlier lectures we have seen methods of finding principal disjunctive and principal conjunctive normal forms. So you can use those methods also to write down principal disjunctive normal form and principal conjunctive normal form of a given formula S. But in this lecture we are going to discuss that if we have principal disjunctive normal form, then how we can write principal conjunctive normal form of that formula using principal disjunctive normal form. And similarly, suppose we have obtained principal conjunctive normal form, then how we can write principal disjunctive normal form from that conjunctive normal form. So that we are going to discuss in this lecture. Now suppose I want to obtain principal disjunctive normal form as well as principal conjunctive normal form of some statement formula which we denote by S. Then first we can obtain either principal disjunctive or principal conjunctive normal form of a given formula S, and using that form we can write down the another form. So suppose I have first obtained principal disjunctive normal form of formula S. Now to obtain principal conjunctive normal form we will follow these steps. After this we will obtain principal disjunctive normal form of negation of S. Now how to write down PDNF of negation S? So we know that principal disjunctive normal form is nothing but disjunction of mean terms only, and we know that in writing PDNF we might have used some of the possible mean terms. So principal disjunctive normal form of negation S will be equal to disjunction of those mean terms which are not used in principal disjunctive normal form of S. So this is going to be disjunction of remaining mean terms. The mean terms which we have not used in PDNF of formula S, those remaining mean terms will be used to write down principal disjunctive normal form of negation S. Now after that we will take negation of negation S. Whatever PDNF of negation S we have obtained, we will take negation of this PDNF of negation S, and that will be our principal conjunctive normal form of given formula S. And same thing we can do if we have obtained principal conjunctive normal form of S first, then after that we will obtain principal conjunctive normal form of negation S, that will be conjunction of remaining max terms, and then by taking negation of this PCNF we will obtain principal disjunctive normal form of given formula S. So it is very easy to obtain both the forms of the given formula from using this method. So that I have written as a remark here: if the principal disjunctive normal form of a given formula S is known, then the principal disjunctive normal form of negation S will consist of the disjunction of the remaining mean terms which do not appear in the principal disjunctive normal form of capital S, and we can obtain the principal conjunctive normal form of S by taking negation of negation S, which we have written here. So this we understand with the help of this example. Here we are asked to find out PDNF as well as PCNF of this formula. So first we can obtain either PDNF or PCNF of this formula. You can see here we have conjunction of these three variables, and here we have two variables. So we are having three statement variables here, p, q and r, and this is having three variables using this AND operator. So we can consider this as min term having three variables. Here one variable is missing and AND operator is there. So it is better that we first find out principal disjunctive normal form. So for that we will write equivalent formula for this in such a way that we obtain min term containing three variables. So first we find out principal disjunctive normal form of this formula, negation p and q and r, and suppose we denote this formula by capital S. Let S equal to given statement formula. Now we know that principal disjunctive normal form is nothing but disjunction of min terms only. That is the definition of PDNF, disjunction of min terms only. So here this is min term, but this is not min term because r is missing here. So to write down min terms here, we can use this formula. We know that if we consider conjunction of p and t, then this is always equivalent to capital P. So using this logical equivalence, we can rewrite this p and q as p and q and t, and we keep this part as it is, negation p and q and r. Then again we know that if we have p or negation p, then that is always going to be true. Okay, we can check using truth table also. P or negation p, here p is true and false, this is f and true, and we are taking OR operator, so this is correct if at least one is true. Therefore this formula is always true. So I can replace this capital T by R or negation R because P and Q are there. So I require variable R. So I can write that T is logically equivalent to R or negation R, and we keep this as it is, negation P and Q and R. So this is using this logical equivalence. Now we use distributive law, P and Q and R, P and Q and R, and this disjunction in between, and P and Q and negation R, P and Q and negation R, and this is as it is, or negation P and Q and R. So here we have used distributive law. Whatever logical equivalence or logical laws we are using, that we will mention in the bracket. Now you can see all these are min terms containing three variables and they are connected by OR operator. Therefore we have S is disjunction of min terms only. Therefore this is principal disjunctive normal form of given formula capital S. Now we want to write down principal conjunctive normal form of S also using this. So for that, first we will write down principal disjunctive normal form of negation S. Now principal disjunctive normal form of negation S will be equal to disjunction of those min terms which are not used here. The remaining min terms containing P, Q and R, we will write disjunction of those remaining min terms, and that will be the principal disjunctive normal form of negation S. So for that we have to first find out that which min terms are not used in the PDNF of variable S. So for that we can write down the min terms corresponding to 3 variables first, and then we will be able to decide the min terms which are not used in formula S. So the min terms for 3 variables, min terms for 3 variables P, Q and R. So first we write down those min terms. First we can write for P and Q, these are the possibilities, P and Q, then P and negation Q, then negation P and Q, and negation P and negation Q, and R is missing here. So first we write P and Q and R, and then P and Q and negation R. Same thing here, P and negation Q and R, P and negation Q and negation R. Here and R, similarly negation P and Q and negation R. Here also and R, and negation P and negation Q and negation R. These are the total min terms for variables P, Q and R. Now we find out which min terms are not used here, or we can write down the min terms used here are P and Q and R, that is this min term is used in S. Then P and Q and negation R, so this is also used in PDNF of S, and negation P and Q and R, so this is also used in the principal disjunctive normal form of S. And these 5 min terms are not used in the PDNF of S. So PDNF of negation S will be disjunction of these 5 min terms which are not used in the PDNF of capital S. So now we write that the principal disjunctive normal form of negation S is equivalent to, now I am writing all these min terms as a disjunction. I am writing disjunction of remaining min terms P and negation Q and R, or P and negation Q and negation R. These two I have written, now I am writing this, or negation P and Q and negation R, then I am writing this, or negation P and negation Q and R, or last one is negation P and negation Q and negation R. So let me check again. The min terms which are not used are P negation Q R, then P and negation Q and negation R, negation P and Q and negation R, negation P and negation Q and R, and negation P and negation Q and negation R. Now we are interested in the principal conjunctive normal form of capital S. So if we take negation of negation S, then we will obtain principal conjunctive normal form of S is nothing but negation of negation S. So now we take negation of negation S. So this is logically equivalent to negation of all these min terms which are written using OR operator. So if we take negation of this using De Morgan's law, we will have negation of this min term, AND operator, negation of this. So negation of each of min terms, and that will be written as conjunction. So now I am writing negation of P and negation Q and R, and OR operator is now converted into AND operator. Negation of P and negation Q and negation R, then AND operator, negation of negation P and Q and negation R, again AND operator, negation of negation P and negation Q and R, AND operator, negation of negation P and negation Q and negation R. So this is using De Morgan's law. We have to repeatedly apply De Morgan's law. So this is using De Morgan's law. Now again I have to apply De Morgan's law here, and we know that negation of negation S is logically equivalent to S. And now if I apply De Morgan's law here, then this is going to be negation of P or negation of negation Q, which is Q, or negation R. So I have to repeatedly apply De Morgan's law here, and again I am applying De Morgan's law here. Negation P or Q, negation P or Q, or negation of negation R, that is R. AND operator, again we apply De Morgan's law here. So this is negation of negation P, that is P, or negation of Q, or negation of negation R, that is R. AND operator, negation of negation P, which is P, or negation of negation Q, which is Q, and negation of R. AND operator, negation of negation P, which is P, or negation of negation Q, which is Q, or negation of negation R, that is R. So we are repeatedly applying De Morgan's law. By repeated application of De Morgan's law, we obtain this conjunction of max terms. Okay, let me check again. Here I am applying negation of this, that is negation P or Q or negation R. Similarly, this is negation P or Q or R. This is P or negation Q or R. This is P or Q or negation R, and this is P or Q or R. And this is nothing but principal conjunctive normal form, which is principal conjunctive normal form of given formula S. So you can see this is very easy. You can first obtain principal disjunctive normal form of a given formula, which is nothing but disjunction of mean terms only. Then you write down the principal disjunctive normal form of negation S by writing disjunction of remaining mean terms. So here 5 mean terms are not used in PDNF of S. So we consider disjunction of these remaining mean terms, and that is our PDNF for negation S. And by taking negation of negation S, we obtain the principal conjunctive normal form of given formula S using De Morgan's law repeatedly. Same thing you can do for writing PDNF from PCNF. First you find out principal conjunctive normal form of formula S. Then you write down principal conjunctive normal form of negation S, that is going to be conjunction of max terms which are not used in the principal conjunctive normal form of S. After that you take negation of negation S or negation of this PCNF of negation S, and you will obtain principal disjunctive normal form of a given formula S. So sometimes they can ask you to write down both the normal forms, principal disjunctive as well as principal conjunctive normal forms. So you can write them in this way without using truth table. If you wish, you can use truth table also. In truth table also you can write using truth table also you can write both the normal forms of a given formula. So this is all about this session. I hope you like it. Thanks for watching.